Dear students, welcome to virtual classroom of Municipal Corporation of Greater Mumbai. I am Sreekumar. The class is for 10th standard students. Subject is mathematics. Let me begin the class.
Dear students, a new chapter is mensuration, which you have studied in the name of surface area and volume in previous class. A part of it is same, and that is 9th standard. That means you will be rewinding or you will be recollecting whatever you have learned in class 9 textbook, surface area and volume. Then you will proceed with a new concept in this chapter. As far as surface area and volume is concerned, you learned about the surface area and volume of cube, cuboid, then cylinder. In class 7th and 8th, you studied about cone, sphere and hemisphere last year. So what I am going to do is I am going to attach the video of class 9, which will cover cube, cuboid, cylinder, cone, sphere and hemisphere, what you learned last year, where you will be getting the full-fledged information. Then I will take in another video the next 2 days regarding something new what is here in this year, that is nothing but arc of a circle, area of a sector and area of segment of a circle, which is in fact because of COVID pandemic, because of less days, somewhat omitted, but some aspect I would be saying in the next video. So my dear students, you will be getting a 9th standard revision, which is useful for you to understand 50% of this chapter. So please watch. Dear students, we are taking a new chapter today. The name of the chapter and the concept is not new to you. The name is surface area and volume. You have learnt how to find out surface area and volume of a cuboid, a cube and a cylinder in the earlier class. That needs to be revised or remembered now, so that you can learn about cone, sphere and hemisphere, its surface area and its volume. I will be making a quick review, very quick review about the surface area and volume of cube, cuboid and cylinder, because you have learned and you know the formula and other aspects related to it. For that sake, let me just show you what are these figures all about and what are the formula related to it in order to learn about it. Okay. So if I think about showing you a cuboid, a cube, which are derivatives of almost same structure, a slight difference, you remember it well. I would like to show you it once again. Let me take this to draw a cube first. Whenever we say cube, cube can be like this, cube can be like this. Most important thing that we remember whenever we think about a cube is its all sides will be equal. That is what makes a cube a cube. If I show the cuboid along with, you will understand the difference. What is that? Whenever we think about a cuboid, it will be having a length, a breadth and height, where all these three can be different. It can be like this, it can be like this, it can be in any format. These all are cuboids. But when all the sides become equal like this, approximately, these are rough diagrams, we call it as cube. So the earlier diagram is if it is a cube, this is a cuboid. Understood. So we are having a cube on the screen and a cuboid on the screen. Let me attend the cube first. If I name the sides of the cube, which is having 6 faces, all 6 faces are like squares. What is the peculiarity of square? All sides are equal. So there are 6 squares. And you know the formula to find out the area of square. Area of a square is calculated by the formula. What is it? The formula is side square, which you have studied in a lower class. Or if you mark the side as L, you will write L square. So in this case also, we will simply mark the side as L, length, breadth, height, everything L. So there are 6 faces, means 6 L square will be there, which will be the formula to calculate surface area of all the sides of a cube. If you are leaving just the upper side, if you think that you don't want to include this upper and lower, this is upper and this is lower according to my view. Depends upon how you are looking. So there are other 4 sides, one at the back, one on the right side, one on the left side, and one which is facing you. So then naturally we can call that as vertical surface area. Correct? Vertical surface area. Vertical surface area. Then it will be only 4L square. All depends upon what is asked. Okay, this is about area, the first part. What about volume? Volume is talking about the total space that occupies. So it includes length, breadth and depth, or length, breadth and height, or length, height and depth, all 3 dimensional. When it comes to volume, 3-dimensional concept comes, the space comes, and you have studied the length, breadth into height, or area into height will be giving volume. What is it? Volume is always explained mathematically as area into height. Into height. If this is what is the volume, area, we can say this is, if you are taking the bottom of this particular area, we will say it will be only L square. And if you are taking the height of it, you have to multiply with 1 more L, then it becomes L cube. This is the formula to calculate volume of a cube. So I said 2 things. One is about cube, the surface area is 6L square and the volume is L cube. This is revision. I stop here. Think about a cuboid. This is a cuboid. If this cuboid, if I think it has got, the way I am looking at it, I can say this is the length of it, this is the height of it for vertical pillar like, and this is the top of it, there also one length over here. And if I say this one, this is the breadth of it, top also, here also, here also. So if I think in the same way, surface area total, there are 6 faces again, but all 6 faces are just like different in its measurement. I can say that the top and bottom, for your understanding, we can have length into breadth. That is, this I took, this I took, this I took, this I took. There are such 2 are there, 2 length into breadth, top and bottom. So that surface is over. And if I say front and back, which I can see, I will take the height and length. So I will say 2 into length into height. You have studied about this. Then I am having my left and right side, where you will be writing 2 times B into H. So when we add all these things, that means 2 into, first one, length into breadth plus length into height plus breadth into height will give you the total surface area of this particular cuboid. Understood? The same way, if I have to calculate the volume, I have to take into length, breadth and height. The same way, area into height. Area is length into breadth and height together will give volume of this cuboid. So these are all things you have studied in the previous class. You can also think about vertical side, whatever is asked. So my dear students, I explained you the surface area and volume which you studied in the previous year. Once again, one more figure you have studied last year, it is a cylinder, which is very useful this year for understanding the volume and area of especially cone, sphere, hemisphere, etc. So let us move ahead. So let me rewrite here. Cube, you understood the concept of what we say surface area and volume of a cube, where we found that the surface area of cube can be, the total surface area of a cube can be calculated by 6L square, and volume can be calculated by the formula L cube. As far as cuboid is concerned, the total surface area can be calculated by the formula 2 into length into breadth plus length into height plus breadth into height, and the volume can be calculated by the formula length into breadth into height. The next thing you have to study is about what we say cylinder. I studied about cylinder, its surface area and volume last year. How a cylinder looks like is also very much known to you. Let me show you. A cylinder look like this. This is a cylinder. It can be like this, like a pipe. It can be a wire which is used for electrical appliances, a small wire, or it can be as big like this for storing water, or it can be in the form of any other purpose. But this is the shape. What is the peculiarity of a cylinder? It is having a circular top and bottom, and then two vertical heights, the sides which we can say. But is it like a cube or cuboid? The thing is having a peculiarity that it is having a curved surface. Because of the circular nature, it is curved. So that is what make this cylinder very unique. This is a curved you can understand. It's a circular here. And there are a lot of peculiarity as far as cylinder is concerned. It has got a circular top and bottom, and there will be a center for it, and there will be a radius for it. Whatever is there on the top, the same radius over here at the bottom. This is named as height last year, and that is the height of the cylinder. So the radius is there, height is there, and when we think about the surface area, our topic today, the surface area can be total surface area like before. It can be only curved surface area. Here I said about vertical surface area, where it was 4 into L square, right? Here also it can be calculated vertical surface area. You will be only considering the vertical part of a cuboid, where you will be having 2L and 2, you will be considering LH 2 times, and you will be considering BH 2 times. That means 2 into L plus B into H will be the formula. Now coming back to cylinder, where you will be having curved surface, total curved surface area and total surface area. You also studied about the volume of it. These are the 3 things you know. I am repeating it because long way to go. So in the case of a cylinder, we say that the curved surface area is this curved area. So the surface area, last year you found that the curved surface area can be calculated by 2 pi RH. And then you studied that curved surface area plus top and bottom, you will be adding 2 pi RH plus pi r square. On rearrangement, we got total surface area can be calculated 2 pi r. You will be having a, there are two surfaces plus 2 times pi r square will come. So naturally we will write 2 pi r into r plus h. This also you studied last year. And volume of a cylinder is calculated by the formula pi r square h. Now, my dear students, this is a revision. This is what is learned in previous class. This is the base of understanding what is there in 9th standard, or what you are going to learn or understand through this video. Okay, and this particular aspect is very important because the continuation is there in 10th standard, where you will be finding it difficult if you did not follow this thoroughly. So what we are going to learn further is about cone and sphere as well as हेमिस्फीयर. कौन बोलेगा तो आइसक्रीम कोन ही याद आएगा, स्फीयर बोलेगा तो क्रिकेट बॉल भी याद आएगा, नहीं तो यू विल थिंक अबाउट प्लैनेट्स as big as earth also you will remember. Sometime you will be remembering a symbol orange when we think about sphere. Cone of course हमारा favorite वही रहेगा, ice cream cone. But here our purpose is to find out the surface area and volume of cone. So first of all, let us analyze what a cone is. Okay, let me show you a cone on the screen. Yes, I told you it can be an ice cream cone like this. If I keep it like this, it becomes ice cream cone, and if I keep it like this, this is some mathematically how we understand cone. You can see that how a cone is, and it can be small, big, any format it can be. So this is a cone, and if you are studying about cone, you should first know about different terms related to cone. The spelling of cone is C-O-N-E. Different terms related to cone is very important because when we studied about cube, cuboid, even cylinder, we had terms like height, terms like length, breadth, right? And in the case of cylinder, we had circular surface, so we thought of area of circular top and bottom. Now when it comes to cone, you can see that there is a area here which is circular again, and this is something slanting, is it not straight like height. If you are thinking about the height of a cone, cone को भी उसका height होना मांगता है. If you are thinking about height of a cone, then you should think about this particular distance from here to here, correct? This can be the height of a cone. I can simply write this as height of a cone, h. h अच्छा नहीं हुआ, ठीक है. This is the height, and this is slanting, which I wrote can be a slant height. Slant height के लिए we can simply use a term L over here. And as usual, we know that this can be written as the radius of the base, right? I think it is not that tough. But when I do this, something came into my mind. What is that? When I did this height over here, radius over here, I could see that the great mathematician Pythagoras talked about the right angled triangle. It appears over here. So it is very easy to measure the height of a thing. वो उतना बड़ा काम नहीं है. It is easy to measure the diameter of the base and find out the R. But to measure the slant height, a little tricky it is. So why can't we use the great Pythagoras theorem for that purpose? If comes, अगर ज़रूरत पड़े तो. So with thinking that in mind, वो सोच के पहले ही हम उसके लिए एक arrangement करेंगे. What is that? This is appears to be the hypotenuse here, correct? This is also hypotenuse. If you consider this as right angle, it is right angle. So in that case, we can write L square. The hypotenuse square is equal to the sum of the square of other two sides. So please keep this in your mind. You can name this as a triangle like A, B and C as center here, and name it, and accordingly you can explain it how this slant height can be calculated using Pythagoras theorem. But अपना काम वो नहीं, our work is to find out surface area and volume of all these figures. Here it is cone. उसके लिए there is no direct method to find out surface area. Direct method जैसे हम in the case of a rectangle converted into cuboid, in the case of rectangle converted into a cube, we could find out easily. Pi r square h we last year calculated opening a pipe and making it into, I think you remember it, opening a pipeline and just opening it into a rectangular shape, and we could find out. Those who don't remember, go back and find out how it was. Here we need a very different technique. I will try to make you understand with some kind of what we say animation done by one of my friend who helped me to do that. I will show you. Please wait. Look at this. This is a cone just made beautiful for you to get into a mood of understanding the curved surface area of a cone. That is the purpose. We can understand how a cone look like. Okay, there is no problem in that. And I also explained what are the different terms related to it that can be easily understood from this diagram. Okay, is there, just to revise that, because I told you the right angle triangle, the height, the Pythagoras theorem, and everything you understood, I am sure. Now, but how to reach to surface area is the important question here. To reach to surface area, we need a kind of activity in order to understand that. Look at this. I will repeatedly show you. The curved surface, which we are going to find out as curved surface area, the curved surface area is that one which is encircling the base. The curved surface is that one which is encircling the base of our cone. You have to look at the motion very clearly. The circular base is covered by a curved surface area and it is tapering here. Tapering means it becomes pointed here. Correct? Understood? So if we can find out area of this one, naturally we are in a position to find out the curved surface area of the cone. But to find out area of this figure, the figure which you are not familiar with, not so familiar, this appears like a sector. Sector is a part of our, what we say, circle. But for that we should know the angle, central angle of that sector. But unfortunately every cone will be having different angles, so that we cannot use. But it is a sector. So our attempt is to find out the area of this piece of curved surface area. So what we can do is practically proving or indirectly doing it. What we can do is, we know this is radius and the spread over here, the curved surface area which is created from this is equal to 2 pi r. Then 2 pi r is a circumference of a circle. This is a circle. This is the circle and this is the radius. Let us look into the motion once again. So this 2 pi r, which is this is 2 pi r. The circumference of the circle is spread over here. That much is clear. Now when it is remaining in the form of a cone, this is equal to the slant height. So that slant height is moving and this becomes the slant height now, right? This is the slant height. So we are having 2 pi r and L as the sides of this particular structure. So let us move ahead to find out how can we do. Let us remove that part from this particular animation. What we will do, we will remove that. This is that where we are having 2 pi r here and we are having slant height here. We are not having idea about the angle, otherwise we might have used the formula of sector. but we cannot. What we will do is we will break this into pieces. We are going to break it into pieces, as many as pieces, small pieces possible, and we will separate it. We will separate each piece like this. Okay, so we know that how many pieces we made, that many pieces we will bring over here and kept together where we know that this particular broader end is coming from here, which is in total it will be 2 pi r. Right? This part, which is broader part of each piece, when put together it will be 2 pi r. And this side, which is vertical, it is equal to L. We know that earlier. So we will keep that in mind and we'll join all these things. In order to join, we will push it like this. And for our astonishment or wonder, it looks like a rectangle now, almost. And if accurately done, it will be accurately rectangle. For that, we should make this into small pieces as possible, so that the curve will not be there, which is practically impossible. But theoretically, if we keep it like this, as small as possible, it will become a rectangle. And it is a rectangle even now. In this rectangle, here broader end is here, broader end is here, broader end is here. That means here it will be pi r, and again it will be here, it will be pi r, and ultimately our 2 pi r will be re-established, and this will be the slant height. To get the area of this rectangle, we only need to multiply pi r with L, length into breadth. तो हमने formula बना दिया. Pi r into L is the formula to find out curved surface area of a cone. L is the height over here, yeah, breadth over here, or length over here. Pi r is the other end. So my dear students, in order to calculate the, what we say, curved surface area of a cone which is having slanting height L and radius R, the formula is pi RL. By heart. Proved. Keep it in mind. बहुत काम का चीज है. Okay? Chalo, we will go ahead. So my dear students, you understood how the surface area, especially the curved surface area of a cone, can be found if you know the radius of the base as well as the slant height with the formula pi r L in the case of curved surface and pi r into L plus R in the case of total surface area including the base of the cone. That you understood. Now regarding volume. Whenever the term volume comes, naturally it comes in our mind that space, या कितना पानी भर सकते हैं, कितना लीटर में, cubic centimeter में, cubic millimeter में सब. So we'll take a cone first, some kind of an activity like so that it will be easily understood. This is a cone. You understand cone what it is now. This is its radius. This is its height. Height over here is there. We are taking another cylinder of same height. Understood? Cylinder and a cone. What is the peculiarity? Both are having same radius and same height. And you know that a cone is having a tapering end. This is cylinder is not having it. Cylinder is having two circular top and bottom. Now what we are going to do is we are going to fill up this particular cone having same height, same radius with water. Thick. And we'll pour that water into this particular cylinder. It so appeared that it could fill 1/3 of the cylinder. If you take one more cup of cone of this one water, it will fill up here. It will fill up completely by the third measure. From that, we already know the volume of cylinder is calculated by the formula pi r square h. Alright? So this will be 1/3 of it. We have to take 1/3 of it, 1/3 of pi r square h. So what happened? In a small measuring system, we found the formula to find out the volume of cone, provided you know the height and radius of it. If you don't know the height, you will calculate the height if slant height is given by Pythagoras theorem. That's why Pythagoras को याद किया starting में. So my dear students, you developed a formula to find out the volume of a cone, which is a new entrant in this chapter or in this video. Okay, so that's not a tough job for you now. Let us go ahead. What is this? Surface area and volume of a cone के बाद we have to find out the surface area and volume of a, what we say, sphere. This is a sphere. So our next task is to find out surface area and volume of a sphere. What is a sphere is known to you. जैसे मैंने स्टार्टिंग में बोला, स्फीयर बोले तो ग्लोब याद आएंगे, किसी को क्रिकेट बॉल याद आएंगे, जिनको भूख लगा है उनको ऑरेंज याद आएंगे, बहुत कुछ चीजें याद आएंगे when we talk about sphere. Now the topic is surface area and volume. Oh, surface area बोलेगा तो अभी तक हमने क्या क्या लिया था? क्यूब, नो प्रॉब्लम, दैट इज इक्वल लेंथ, इक्वल ब्रेड्थ, इक्वल हाइट. Cuboid, there is length, breadth and height. Then cylinder, no problem, there was a height and a radius. Then you studied about cone just now, it also has a got height, radius along with a slant height. Now, as far as sphere is concerned, unfortunately or fortunately, there will be a center for a sphere because it is made up of concentric circle and there can be a radius. The radius will be like this, and if you take it full, it can be the diameter and it can be the height of it. There is no concept of height of a sphere, कभी बोलता ही नहीं है. It can be the diameter of the sphere. And if you cut the sphere into two halves like this, we can call it as hemisphere. लेकिन प्रॉब्लम ये नहीं है, हमको सरफेस एरिया एंड वॉल्यूम के बारे में सोचना है. In order to explain how the surface area of a sphere is calculated, you need to go through certain experiments. But experiment will surely prove that. One of the experiment is like this somewhat. If you have a cricket ball or something in your hand, think about this globe itself. I will remove all this, whatever I have drawn on the globe. Just removing whatever I have drawn. Okay. Suppose that this is a cricket ball or something like that, and we are going to stick over this thread in such a way that इसको ऐसे thread से ऐसे इसको ऊपर चिपका देंगे. Thread एक के पीछे एक ऐसा thread चिपका देंगे. So you can cover the whole cricket ball with thread. Correct. तो ऐसा situation आ जाएगा. The ball is full of thread and thread only. Then the next thing is you need to draw 4 circles. You need to draw 4 circles of the radius equal to the cricket ball which you have drawn. You will be drawing 4 circles of same radius. If you draw 4 circles of the same radius and remove the thread from there and keep the same thread inside the circle like this, you will find that you can exactly fill up the thread in 4 circles of same radius. And we know the radius of this, and the radius is equal to this. So if this is pi r square, the 4 circle will be 4 into pi r square. Thus the formula is 4 pi r square practically. Your textbook is telling some other idea. What is the idea? According to the textbook, take a Mosambik. Mosambik to globe ki jaise hoga. Cut it into 2 pieces like this. You will have 2 pieces, means this will be the diameter then. And draw a circle according to this same size. Draw 4 circles. 1, 2, 3, 4 circles here, one after another. Now remove whatever is there inside the Mosambik for making juice. आपको juice पी सकते हैं. But the skin you will cut it into pieces and spread over here. इधर spread करेंगे तो मालूम पड़ रहा है कि 4 circle जो आपने बनाया ना, these pieces will be easily filled completely perfectly in 4 circles. The same principle. इधर thread डाला, इधर मौसम्बी का छिलका डाल दिया, 4 circle में perfectly बैठता है. Again proving that the surface area of a sphere is calculated by the formula 4 pi r square. इतना ही मुझे आपको बताना है. So what you should know? You should know about what we say the radius of the sphere in order to know the surface area of it. If you want to know only half of it, that was hemisphere, you will use 2 pi r square, that is this much. If you are adding the open area over here, you will use 3 pi r square because there is one more pi r square, the open area, open surface. So my dear students, as far as sphere is concerned, you are having formula for total surface area as 4 pi r square for a sphere, 2 pi r square for hemisphere, and 3 pi r square for total surface area of a hemisphere. Correct? All these are games of formula. अभी मैं formula बता के जा रहे. You have to apply this formula to solve the problem. Oh, एक चीज भूल गया. I have to find out the volume of a sphere. Volume find out करना है तो वापस वही याद आएगा. Like what we say, we will remember about water filling in bottle, the way we found the volume of, how to calculate the volume of a cone. The same method can be adopted. Understood? So such things we will try in the case of what we say sphere also. Let me move ahead. What I have done some trick for you. Suppose that this is a circle, you know very clearly. अभी मैं इसमें से एक sphere बनाना है तो you know that it should be 3 dimensional. I am making it a sphere. अभी आपको थोड़ा एक sphere like appearance आ गया. I am making it simple for you. And if I cut it into half, okay, now it is perfectly a hemisphere, no doubt. This is a hemisphere now. Same other पानी भरने का काम करेंगे. What I will do is I will take a cone of same size. Why size? Same radius. ये जो radius है ना, this radius same. This one and this radius same. This one is again radius. This height is also same radius. Actually, this is a height otherwise. This is the height otherwise, but in the case of sphere it will be radius again. Now again the same principle what we use in the case of cone. We are filling this cone with water. I know the volume of cone we found from cylinder as 1/3 pi r square h. This is the volume of a cone, correct? Volume of a cone. So I am filling this cone with water. Going to pour this into the हेमिस्फीयर, क्या हुआ, कोण जितना है उतना ही भरेगा ना, it will not fill the hemisphere. Taking one more full of this cone, if I put it into that, I found that it completely and exactly fills the hemisphere. From this I have to conclude that if I take 2 times of 1 upon 3 pi r square h, which is the volume of one cone, I am getting the volume of hemisphere. This is what I am getting. Now, here the interesting thing is, here R and H are same. I told you at the beginning. So, this can be written as 2 upon 3 pi R cube. This is the volume of hemisphere. If this is the volume of hemisphere, 2 by 3 pi R cube, then naturally 2 times of that will be the volume of a sphere, that is 2 into 2 upon 3 pi r cube, which is equal to 4 upon 3 pi r cube. Understood? So this is an activity, or this is a method by which we can, in the case of cone also we did the same, but in the case of cylinder last year we exactly calculated converting cylinder into a rectangle. But when it came to cone volume, we found that 3 cone volume is equal to the equivalent cylinder volume having same height and radius. Now from the same cone we could find out that 2 times the cone volume of same radius and height, radius and height are same for hemisphere. We found that 2 times of that is equal to the volume of hemisphere, and where we get the formula 2 by 3 pi r cube as the volume of hemisphere, and 2 times of that 4 by 3 pi r cube is the volume of a sphere. So slowly and steadily we reach to the basics of surface area and volume of different figures, especially about cone you studied, the surface area of cone, curved surface area, in that case pi rl you studied, and total surface area pi r into L plus r you studied, and you also studied that 1 upon 3 pi r square h is its volume. When you studied about sphere just now, you found that the total surface area is 4 pi r square, that of hemisphere is 2 pi r square, and the total surface area of hemisphere is 3 pi r square, and the volume of sphere is 4 by 3 pi r cube, and that of hemisphere is 2 by 3 pi r cube. मैंने एकदम रफली लिख दिया, मुझे मालूम है आपको भी लिखना ही है, आंसर शीट में फॉर्मूला लिखना है, सब्स्टिट्यूट करना है, प्रॉब्लम सॉल्व करना है. But you need imagination. Imagination how this figure looks like. For that you should do the examples, understand the examples and do the exercise. Next video will be on that, no doubt. But जो smart student है ना, अरे हमको तो समझ में आया. The formula of cube, cuboid, cylinder, cone and sphere and hemisphere. We are smart enough to solve the problem provided problem is understood. Along with that, I would like to say that the problem will be giving you pi is equal to 22 upon 7 sometime. Sometime it will give us pi is equal to 3.14. Whenever you are doing problems related to this kind of question, the unit should be checked, or unit should be same. Unit means अगर centimeter में तो सब centimeter, millimeter तो सब millimeter, and most important, you should draw a rough diagram if not given before starting the exercise or solving the problem. Wish you all the best, and I hope that my help won't be required for you to solve the sums, because this is game of formulas. Thank you. Now click on the subscription button below to subscribe the channel, then the bell button to get the notifications of the new videos. Thank you.